Hello, in this video we're going to look at how to find the length of a side of a right angle triangle using our primary trig ratios. And in this specific case we have two sides we need to find. We need to find side P and side Q. So the first thing I notice about this situation is that it's a right angle. I'm given one angle of 45 degrees. Now, a little note here. You might notice something about this triangle which actually allows you to reduce the amount of work you need to do for this problem. I'm actually going to go through and calculate P and Q manually, and then afterwards I'll talk about the little trick in this problem to reduce the amount of work you have to do. So you can pause the video and think about what that trick might be before watching this whole video. See if you can get it. Okay, so I know I need to use my primary trig ratio since I have a right angle triangle. So I'm going to write down SOHCAHTOA, and I'm going to first look at solving for P. So I have my angle of 45 degrees. So remember we take the sine, cos, or tan of an angle, so I check mark SCT, and relative to 45 degrees, P is the opposite. So I need to have the opposite in whichever primary trig ratio I use. And 5.1 is a hypotenuse, so therefore, perfect, I use sine to solve for P. So therefore, let's set this up, and therefore I say sine of 45 degrees, remember to put that degree symbol, equals the opposite, which is P over 5.1. So now I'm going to multiply both sides by 5.1, and I'm going to get P is equal to 5.1 sine of 45 degrees. Now I'm going to put two little arrows here. The left-hand side, we're going to work through this with our calculator. So I'm going to type this directly in my calculator. So I'm going to say 5.1 times the sine of 45 degrees, and I'm going to hit equals, and I see that I get 3.606. So P is approximately equal to 3.606. Now I didn't check the mode of my calculator, so let's make sure my calculator is in degrees mode here. So let's just clear this. Remember, I can check if it's in degrees by taking the sine of 30, and I should get 0.5. So I do, so I'm good. Now, some people might have learned that sine of 45, there's an exact value for that. And the exact value for a sine of 45 is 1 over root 2. So we could say that P is equal to exactly 5.1 times, let's clear this up, P is equal to 5.1 times 1 over root 2. That's an exact value for the sine of 45 degrees. If you don't know that yet, we're going to get to that and talk about some special angles that you should know the sine, cos, and tan of. So therefore, P is exactly equal to 5.1 over root 2. And let's just check to see if I get the same value. 5.1 divided by root 2. And notice I get the same value. So at our point right now, we want to be able to be sure we can do this with a calculator. But for those of you that know the exact value of sine of 45, that's another way to do it. Okay, so now let's solve for Q. So again, I can write down my SOHCAHTOA, and let's check mark the various things to see what we have. So we're working with the angle of 45 degrees, so I can take the sine of 45, cos of 45, or tan of 45. Q, relative to 45, is the adjacent, so adjacent, and 5.1 is still a hypotenuse, and I see that I use the cosine ratio. So therefore, the cos of 45 degrees is equal to the adjacent, which is Q over 5.1, which is the hypotenuse, So I'm going to multiply both sides by 5.1. So I get 5.1 is equal, oh, sorry, let's rewrite this. Q, let's actually write this way. 1 times cos of 45 degrees. So Q, and again, I can do this. I can do this using a calculator. So I can say 5.1 times the cosine of 45 degrees. And I see I get Q is approximately equal to 3.606, or some people might know the exact value of cos of 45 is 1 over root 2, so Q is equal to 5.1 times 1 over root 2. Let's scroll down just a little bit here. So Q is equal to 5.1 over root 2. So now my question for you before we wrap up here is, we have these two values, but notice anything? And what you should notice here is that P and Q are the same. And this is the trick. This is the trick that you can use to work through this problem. If this angle is 45, this angle is 90, that means this angle here is 45. And remember, largest angle, largest side, and then the smallest angle will be across from the smallest side, and the middle angle will be across from the middle side. But in this case, if my other two angles are equal, these two sides must be equal. It's an isosceles triangle. So that means you only actually have to calculate either P or Q in this problem. So that's a little shortcut there. Last little points, just to kind of wrap up here. A couple little things we want to make sure we pay special note of. First thing, make sure you put in those degree symbols there, right? Always write that degree symbol in there if you're working in degrees. Second thing, make sure you're using approximate symbols if you're giving an approximate value. If you're not sure how many decimal places to take it 3 decimal places. That's usually a safe bet. The last thing to kind of take away from this one, the last point, and actually I'm just going to say it as opposed to write anything down, is notice we calculated P first. We could have then used P to solve Q, but if we can avoid using a value that we've calculated to solve some other unknown in the problem, that's probably a safe thing to do, because if we made a mistake finding P, that mistake will carry on to Q. Likewise, if we use an approximate value of P, we're then going to only find an approximate value of Q. I hope this video helped.